Bueno, hola.
Good morning. We would like to continue talking about the architecture of complex systems, in this case, the developments you make. And this year, we had the pleasure with Gaston of discussing the matter with you, discussing the systems, doubts you had, and solve doubts concerning the complex environments in which you're working and how to move to different schemes and solve some problems. And in other cases, there were companies that were just starting, and with 2019's technology, they wanted to do things well and build for the future. So this was the motivation for this series of talks. That was the starting point, seeing how we can build nowadays and how we can move to other schemes if we are not on the ones we would want. So let's describe the reality of the moment. Is this a reality? Is it a reality we want to see it? I get up every day, I add a few objects, and I have a lot of productivity. And I end up making a web application and a database. This is today's reality. It's the truth. It is the truth, but only part of it, because the truth is a little more complex. We are in a world at the moment where we cannot forget that we're going towards the multiple experiences, and the solutions we are creating are for ecosystems, or at least they are for an enterprise that have multiple realities and multiple users. And we are going towards solutions that are not merely a web app and a database. I'm not telling you anything new. GeneXus has always been an integrator. It is used by your companies to integrate different systems. So whether you make some of the components or whether you delegate some of the components to third parties, you are always building complex systems. Besides this, the world is becoming more and more complex. This is a multi-experience solution you might be creating today, but it has multiple components. And this reality is without any doubt more complex than the previous one. So the matter becomes more relevant. If we discuss it by analyzing the systems, we could divide this in subsystems. You're probably thinking of making not just one part, but all of it. So if I have to do all this, how do I build it? How do I work in GeneXus? This is today's world, the world in which we find ourselves when we develop systems. But something else is valid. The world today accelerates. No matter how agile you are, or whether you are working well or fulfilling your business needs, making the applications you need to make, there's one word that is true. The rhythm that you have at the moment to release softwares is going to accelerate too. So the key question is the following when we're going to build a system. How often do you need to release what? This was said by Grady Booth in an event in San Francisco. He said, whatever comes, you can come and ask me about architecture. I am asked how to make architecture, but my question is, how often do you need to release what? How often do you need to release what is the question that will determine all the rest. I can define the architecture on the basis of your reply, but there are other questions, and these are some of the questions we have been asking ourselves in the teams with which I have been working. There are many questions on this point, but they're all variations of the question that this gentleman asked. So the reply is it is necessary to become more and more agile. And as Gaston said, and we have been repeating, there is a component which is the teams and the processes, and then the rest goes to DevOps. But I'm not going to get into that. I'm going to get into the architecture and the tooling I will be using. So architectures and tooling. What is the architecture we are going to choose? We will have more flexibility and probably more agility if we have, as Gaston said, a certain DevOps procedure. But unarguably, complexity also increases in the solutions. I need to start orchestrating the various solutions and coordinating the various teams. So the complexity is going to increase on the right-hand side. And for the left, on the left, there's another point which is important, data consistency. I may lose it when I go right, but we must not forget what the title says. All of us who build solutions with GeneXus are building data-intensive applications, and the data are an asset or the main asset in our companies. So this is a point in that is forgotten very often by books, but we cannot forget it in this community. Data consistency. So we are going to analyze all these points and start with a monolith. I have a knowledge base, a web application, and a database. This is what I generate, which is similar to that simple scheme I showed you at the beginning. I have a web app and a database. What do I have here? I have consistency, and I can work on my knowledge base and have access to any table in my database. Everything looks consistent, everything is integrated, I have cohesion. It looks very good. Now, what's the point? It's all or nothing. I'm in an all or nothing situation. I have to update one part of the screen and I have to do a redeployment of the solution. I have to touch one part of the database and I have to download the whole system probably in order to make it. I have one performance problem in a little part and I no longer have availability in the whole solution. So it has a lot of advantages, but it has also some disadvantages. What are the tools that I recommend in GeneXus for the monoliths? Some of them are not indispensable. You made applications in any GeneXus version, like the ones I just showed. The things I'm showing now are relatively new. They appeared these last few years. Now, my recommendation for you to look towards the future is to take all this into account. In your database, use the modules, make modules in your knowledge base. This will give you flexibility to move towards a different kind of architecture. Use the GAM and integrated security for the same reason, to increase flexibility. And use log API, which came up in GeneXus 16, and you can add it to your procedures. Log information on yourselves under different topics to know what's happening in your systems and which part of your knowledge base is doing what and causing a certain problem or just showing information. And from now on, use a deployment unit object. Even if everything goes to a web app, all of your mains have to be represented in this deployment unit object, and from there you carry everything for security reasons, and so that conceptually in your knowledge base you know what will be going towards that single web app you have. Let's look at a case. the macro or the macro or the microservices. We have a knowledge base, and here we have a system and a subsystem I and a subsystem N. They come from the same knowledge base and they go to the database. And we have the web app against the same knowledge base. Here I need to have an interface. If the same user needs to serve from one part of the subsystem I to the subsystem N, I will have to solve in one way the way it's going to do it. If it moves to another web app, or in the same web app I start showing components of the previous one. So there's some integration work and decisions to make that are required. So I still have the performance, I have the acid of the database, I have independent web deploys. So if one part of the application falls, maybe the other one won't be affected. I deploy one of the web apps and the other one continues functioning. I don't have a problem with availability during the deploy, but I'm still working against a database. The scalability is in the database. Both web apps are independent, but the bottleneck may be in the database, and if it falls, both systems will fall. So I have to solve the problem of integration too. What do I have in GeneXus for this purpose? I still have the modules and the GAM, and if the user is going to move from one web app to the other one, I need to solve it without the sign-on, so it stays in the same environment and does not need to log in again. Deployment unit is now mandatory, and then I need to do this. Either I have a menu and I have a dynamic call to the other web app, as Google does. I go from Gmail to Google Drive, and the single sign-on is solved. I'm still logged in there, and I move to the other one. Or I have an embedded page somewhere in my web object. I have a link to another one, and inside the same screen, I see the other one. This can function if I don't have much interaction. This is a tooling I have. If we are looking for more, I can go to microservices and I can separate the knowledge bases. I'm working in two different knowledge bases. And this is a case of microservices that have certain specific features. I have both subsystems, but it's all in a database, even if each system has its tables and indexes. So KBI impacts its indexes and KBN impacts its own indexes and tables. But physically, let's say that I can still have everything in the same database, even if in different schemes. Everything goes to the same database, and I'm not in the case in which I have a system in Tanganyika and the other one in the US, and the databases are separate. They may be in different web apps, but they are near enough to the database so as to have them all here. And this happens a lot. This case happens frequently, and it has certain operational advantages if we have both sets of tables together. So what happens in this case? I will want to have access at a certain point to these other tables. This web app will want to have access to these tables. It's going to happen. And what's the way of doing it traditionally in GeneXus? There are transactions in the KBN, and I do an export of the structure of the transactions. Maybe I duplicate the transactions in order to have clean transactions. I pass the structures to the KBI, I add the data use, and here with the transactions against these tables and with the data views, these tables are not impacted. And I may have here all the for each, and I can still keep the performance as it is. Now, what happens? Here, I may have business components, and I have rules associated to these transactions. When through the I system they are accessing these transactions and these tables, they are not going according to the rules I defined in these transactions. So what happens? Something new. If I have modules, I have one in the KBN, I package the module, I distribute the module, and I bring it to the KBI. And there I have an API against that module. Inside the module, I have the binaries of the transactions, for example, and the API allows me to do an insert on the tables of the other KB. In GeneXus, I see this as an API. That is to say, the interface of the module is an API in the knowledge base in which I imported the module, and I also have the binaries that I brought from the other KB. All this has the functionalities of distribute package. So the binaries here end up running and having access to the tables of the other KB. And when this happens, since I packaged the business components, the insert, the delete, etc., maybe then in that case they follow the business rules I defined. Now, what happens if I use this for it? With this model, I'm not able to do a for each against the tables of the other system, so I'm losing the joint. So what do people do? They do both things. They take the structures and the modules. That is how people work nowadays in GeneXus 16 if they want to be in this scheme. And with this, they have the best of both worlds, the performance of the joints, and through an agreement, I am enforcing the business rules. I have the advantage of making independent deploys, although they have a certain level of coordination, just in case there are inconsistencies. And the cons are that I need to coordinate the distribution of the transactions, the data views, and the modules. The good thing is that if all this is automated with DevOps, every time there are changes in these structures, I need to build tools in order to check them and make sure that there is consistency between the two systems. So this is how we work with microservices at the moment. There's still consistency in the data because I don't have problems in that sense. The modules are fundamental. If in the monolith you started working with modules, it's much easier to go into this scheme. And with the GAM thing, with the GAM, it's the same thing. You add SSO. The deployment unit is also mandatory, and we just add the package module export import as a GeneXus tools to achieve what we just seen. Up to now, we were talking about the consistency in the data, but now I have a system in Tanganyika, one in the US, and both databases cannot be together. So because of a question of performance, I have the same table in both systems. So first I'm going to try to call the services from the other system, and I do it with an API. And here there may be issues, as Gaston said. What happens if the other system does not realize that I sent a notice, or maybe I do the same things twice, or there may be a problem of coordination or synchronization of both databases. As Gaston said earlier, it is necessary to define very clearly who owns the data and whether I'm in a scheme of pull and push. Either I send the data each time they change, or he asks me and I have webhooks. I say I updated the data, and then the other one calls me to ask for the new data. So it will be asynchronic or almost asynchronic data, but in any way, there is a duplication of the data. So the problems are clear, and I invite you to watch a talk by Jason Maud, who works for a digital bank. He says the scheme I made, I don't call microservices. I called SES SES architecture, self-contained system architecture, and he defined some more rules in order to achieve power when one system tells the other about a certain event. In banks, this is extremely important. Uh, and he explains very well how he achieved this and what are the rules that he established in his institution so as to achieve this purpose. And I learned a lot in that talk. So let's continue talking about the possible inconsistency in the data. And it may be that we lack synchronization completely. I may have an event bus in the middle, but I can make a change and let the event bus know. I don't want a system in particular. All the events in this table are sent into the event bus, and there will be one or n systems, and I don't uh, worry about that, that will learn about the change. This is the way in which systems operate in the Panama Canal. They have an event bus, and as ships cross the canal, and events associated to these ships take place, and there are multiple systems of multiple companies that need to know that this is happening. All those who need to learn about it are connected to the event bus and will know that the ship has crossed the first locks, or that it's waiting for authorization to cross the canal, or has no authorization and needs another inspection, or needs to go and correct the issues they may have before crossing the canal. So there are many companies and many institutions that are connected to the event bus in order to learn about what's going on. Here I also need to define what's the system that's the owner of the data, but I'm in a scheme of publish subscribe. In GeneXus, what we did, well, we have the REST and the Open API for these cases of services. Then we have the socket as a communication mechanism, the first two for synchronic cases, where I have to take these into account, these considerations that Jason from the bank just I that's said, and I just showed you, and then I have the sockets and an Apache as used in the canal. So to sum up, what have we been doing in GeneXus 16 in order to produce all this? We have the isolation level in each one of the data stores at the moment. You can have one in Oracle or against Oracle, then the read committed in SQL. It doesn't matter. Each one goes through one data store, and we implemented the read committed in the SQL server. We also work in navigation performance. And with regard to the APIs, we implemented the Apache Kafka, the sockets, and the logging that goes against log4j and log4net. It is printed in the file with a standard format, and then other tools can read it so that it can be analyzed. And thus, we can monitor the system and it can be observed. In the IDE of GeneXus 16, we implemented the package module, which can then support the procedures that have access to the database or the business components that access the database. We also worked on the build's performance, which is especially important in very large databases or knowledge bases. The feedback we had was very good. We did the build at the level of the deployment unit. If you're going to deploy a web app, you can right-click on that deployment unit. And last week, we have built custom built, and every time you build, multiple steps are executed right now, but then you will be able to define just one build that will follow just one of the steps. For example, one of the steps of the build is the configuration of the configuration files. So you can do my custom build. So you have actions that are much more atomic for some concrete scenarios in GeneXus. And this also helps the very large systems or knowledge bases. And then the new output window scales much more. When you work in the IDE and the build is very large, there was a deceleration, but now it works at scale and it has a better performance. In the GAM, you can connect with the entity provider SAML 2.0. We also have the security token service. This was requested by AGESIC, and thanks to that request, we implemented it. And without the sign-on, among different web apps, we can have just one access. So what's next? We are still in touch with many companies to see what we can improve in these scenarios. But I could summarize, could be summarized in services management, but actually it's not a summary. This is the one that is going to have a higher impact. This is where the components are more important. At a certain point, databases were the most important thing, and they still are. But I believe that services are equally important or have been growing in importance. The integration of services and the management of everything that is related to services. And Alejandro Paniza will tell you more in this regard in a while. So, to close this talk, my recommendation is that you work with DevOps or help your companies to move towards DevOps. Adopt these practices. It's a change in culture, in tools, in the way you work. So adopt DevOps and associated tools so that you can have speed. You are going to need them to have more and more speed in your releases. How often do you need to release what? That's a good question, and build on the basis of the reply. Choose the architecture that is more convenient to you, that you can do with GeneXus. but mostly built on top of modules. Many thanks.
Gracias.